Alright, so good. So today we're going to continue our lecture. So last meeting, I think we talked about the WBS or the work breakdown structure. So your activity was to prepare a list of activities if you're going to do a two-story residential building. For this week, we're going to look into the tools for planning projects. So, um, okay. So this is from our resource class. So this is a book that I'm working on integrated construction project management. So hopefully it will be published within the year. Okay. So what are the tools for planning projects? So project management software is used for project planning, scheduling, resource allocation, and change management. Numerous project management software packages exist in a range of formats, including desktop PC-based, server-based, web cloud hosted, and the packages can be licensed to a single or multiple users. Most common packages are sophisticated enough to allow the planning and management of project activities, including scheduling, cost control, budget management, quality management, reporting and documentation or administration systems. So there are a number of discrete planning activities and projects discussed throughout the module and well-established tools to help manage each activity. For example, you have the WBS, the PERT, control charts, scatter diagrams, etc. So modern project management software packages provide an all-encompassing tool that enable project managers to adjust and control their planning activities in a central document repository that can be shared across the project team and with other stakeholders. So the key role of project management software includes, so if you're going to use project management software, some of its key roles include project planning, which is to create the WBS, the project schedule, the plan resource, and visually display task dependencies. Then you have task management to create and assign tasks, deadlines, and status reports. Document sharing and collaboration to share data, documents, and reports with the project team and other stakeholders via a central repository. Then calendar sharing, collaborative tool to schedule project meetings. Then time tracking to track progress of individual tasks and phases as well as overall project progress. So okay class, so if you look into this, I think there's an emphasis class on central repository. So this is especially true if you are working on large structures. For example, airports, hospitals, mega projects, okay, and projects exceeding a billion pesos or $1 billion. So you may need a central repository to monitor everything. So, a primary reason for using project management software packages for developing project schedules and project plans is that these packages have standard templates with the capability to reflect changes instantly in the entire project plan. So I think that's the main reason, class, why it's really crucial for you to know about the different project management software packages. So I think one semester is not enough for me to discuss everything. So I encourage you guys, as early as now, do some research and then try to learn um, some of these new softwares. I think you could find a lot of tutorials since this is the era of the information superhighway or the internet. So this is particularly useful when projects are complex. So like what I've said earlier. So if you're doing nuclear power plants, if you're doing complicated structures, you may need a central repository and a good project management software. Have long durations and span many activities. So off-the-shelf software packages are easily accessible to so information and plans can be shared quickly across project stakeholders. So why is there a need class to share information? The answer to that is because your stakeholders need to be well informed of what is happening in the project so that you'll continually get support. Support is really important in order for the project to continue. So there are several project management software packages available in the market as well as open source. When you say open source, it's free. Free project scheduling tools available for most operating systems. So the basic packages provide features that range from the more elementary planning activities such as project scheduling, cost control, budget management, resource allocation, to more sophisticated activities such as team collaboration, communication, quality management, and dynamic documentation development. So if you could find a software class which would allow collaboration of teams in different locations, so it would really be nice. Then what's important is that when you collaborate, you also generate data on what happened during the collaboration process that you could easily track changes. Then project management software applications assist in identifying critical paths in projects. Okay. So in the past class, you'd really have to do this manually. Okay, so in order to determine the critical path, you're going to compute it manually. But now, since our project management softwares, all you need to do is to be really well versed on creating the WBS or the work breakdown structure, so that when you have the list of activities already, you could all input that into your software, and then you could directly determine what the critical path is. Then documenting plans. Of course, documentation is really important, especially in large infrastructure projects. Assigning resources to tasks. So when you assign resources, it means that assigning budgets for different tasks and assigning materials for it. And tracking progress, managing budgets, and analyzing a range of project data. These software tools can be used to adjust allocation of resources to various project tasks. This adjustment may be needed if the same resources is required in different projects at the same time, a situation that can be common in multi-project and program environments. So this software can help in identifying conflict and resource allocation at the planning stage. Okay, so I place an emphasis on software class because um, I think we're already behind other countries. Because here in the Philippines, we're still doing it manually. So though it's good that you know how to compute it manually, but if you have softwares, you could perform a lot. You could concentrate more on the project. You could concentrate more on how you're going to use the tool, and not in the computation, and not get lost in translation when you compute. Okay. So what are the tools and techniques in planning for quality? So plan quality management is defined as the process of identifying quality requirements and or standards for the project and its deliverables, and documenting how the project will demonstrate compliance with relevant quality requirements. That's from the PM book or the Project Management of Knowledge 2013, page 231. So planning for quality is important as the process guides and directs how quality will be managed and validated throughout the project lifecycle. The business case for planning for quality often centers around two measures, which is the cost-benefit analysis and the cost of quality or COQ. Cost-benefit analysis looks to compare the cost of the desired quality standard to the expected benefit of each activity. This ensures that the quality is assessed to ensure it's not too low or as to cause future problems or costs. And that is not too high where the benefits do not outweigh the cost. So this is a key measure in planning and agreeing the quality requirements in the project. Meeting the agreed quality standards has additional benefits including less work, high productivity, lower cost, and increased customer and stakeholder satisfaction. So COQ includes all costs incurred in preventing non-conformance to quality requirements. Costs are in two categories, the cost of conformance and cost of non-conformance. Conformance cost includes preventive costs, such as training, equipment time, appraisal cost. So in the field of architecture class, you could relate that let's say some clients say that architects are expensive, okay? But hiring an architect is a preventive cost so that some problems that might arise during construction can be prevented. Okay? That's why you are trained to do planning and design from and also building technology. Okay? Take note that your planning and design is design 1 to 10. So you have 5 years of education in learning planning different types of projects from the small two-story residential is quite easy, and then up to airports and large-scale mega projects and also hospitals, malls, and a lot of things. Okay, so non-conformant costs include internal failure cost. Okay, so if you're not going to conform on something, of course, the consequence will be failure cost, such as rework, scrap, and external failure liabilities, lost business. Failure costs can often be categorized into internal and external. Okay, so internal found by the project, external found by the customer. So there are a number of tools and techniques that can be used to plan for quality control. So the project management body of knowledge identifies 7 tools known as 7QC, such as, for example, the cost and effect diagrams, also known as the fishbone or Ishikawa diagram. You have the flowchart, you have the check sheet, we have the Pareto chart, histogram, control chart, and scatter diagram. So this is an example class of a cost and effect diagram. Okay, for example here, um, if this is a general problem, then its probable cost could be the equipment, the process, or the people, or the materials, also the environment, or even the management. Okay, so if you look at this, it's like a fishbone, as the name implies. So cause and effect diagrams place the problem at the head of the fishbone, like here. The problem is often written as a problem statement or an objective to be achieved. The problem or effect is then used as a starting point to trace back the causes of the problem. The diagram is used to many possible causes for an effect or problem and sort the causes into useful categories to enable action. Then you have what you call a flowchart. Then flowcharts, sometimes known as process maps, are used to map the procedures in a process as sequential steps. Flowcharts can be used to help to understand and estimate the cost of quality in a process by using the workflow branching logic to estimate the monetary value for conformance and nonconformance. Then we have what you call a check sheet. So a check sheet is a structured prepared form for collecting and analyzing data related to quality. It is a generic tool that can be adapted for a wide variety of data gathering purposes. It can be used to organize issues by date, event type, or any other useful data relevant to a potential quality issue, and are often subject to further analysis to identify trends and underlying patterns. Then you also have what you call the Pareto diagram. So Pareto diagrams are used to show on a bar graph which quality-related factors are more significant. So identifying the vital few is important as this will cause the majority of the problem's effects. Okay? So I think this is the most common diagram that I see, especially in the use of statistical software packages. So histograms, the most commonly used graph for showing frequency distribution, or how often each value in a set of data occurs. So they report and describe the central tendency, dispersion, and shape of a statistical distribution, although it does not consider the influence of time on the variation that exists within a distribution. Then you also have what you call control charts. So Control charts, in comparison to histograms, are used to study how a process changes over time. This is useful in assessing quality and risk as it helps to determine the level of stability and predictability of a process or performance. Upper and lower control limits are based on requirements of the project or contract and represent the maximum and minimum values allowed. In some projects, there may be penalties imposed for exceeding the agreed control levels. So the project management body of knowledge determines a process to be out of control if a data point exceeds a control limit or if 7 consecutive points are above or below the mean. Control charts are most commonly used to track the performance of repetitive activities. In manufacturing environments, they are also used to monitor cost and schedule variances, volume and frequency of scope changes, or other management results to help determine if the project management processes are in control. Then we also have what you call the scatter diagram. So scatter diagrams are used to graph pairs of numerical data, one variable on each axis, to look for potential relationships between two variables. This is used for quality planning to ensure correct controls are in place for factors that might cause quality problems. The direction of any correlations found may be proportional if it's positive correlation or inverse if it's negative correlation, or a pattern of correlation may not exist, which is zero correlation. Okay, so we'll end our lecture on that one. For the next week, we're going to talk about project scheduling. Okay, so if you have any further questions or clarifications, tasks, you may send a message to me anytime, then I'll answer it. Then, of course, you could also schedule um, synchronous lecture activities wherein you can ask me anything. Okay? Especially the applications, these different rules uh, in the real world or in real projects. Okay, so see you next week and stay safe.